Hey everybody, MS Farzan here, and in this video we're going to continue to build our 2D card game using Unity and add some game logic to it so that it feels like a real game. Now, it would be totally impossible for me to anticipate all the different types of card games out there and all the different types of logic that would be needed to create them. So we're going to work through a couple of exercises looking at one of my own card games, since that's what I'm familiar with. And if you're trying to make a, let's say, a Hearthstone clone or something that's similar to Magic the Gathering, there are plenty of other tutorials out there that can help you to do that. And you are now armed with all of the knowledge that you need to understand what they're doing in those tutorials. So we're going to take a look at a specific game logic tutorial here using one of my games, and hopefully the knowledge that you'll gain through it will empower you to make your own game, specifically if it's not a Hearthstone clone or something that is similar to Magic the Gathering or similar games. I will link the code to this, to everything that I'm doing here in the description for this video. And it will be on a new link that we've used before, so that we'll preserve all of the information that you've already seen in previous tutorials. And I must say that if you've come to this video without doing any of the tutorials that precede them, I highly recommend working through them, as I won't be spending too much time discussing the details of things that we've already covered. So it would be really helpful to watch the tutorials before this one, before we dig in and take a look at the new material. I'll also say, as a final caveat for this video, that there are some funky things in working with Unity and using Mirror when you're attempting to make a card game using the canvas as we're doing, and working with a host and client relationship. Like we've done in the videos so far, we've been, instead of having two clients that are communicating with one server, we're asking for one of the clients to actually act as the server as well, making that client the host. So it has a server and client component to it, and then another client is just a client. So we have to think through, what does it look like to be a client and a server, and what does it look like to be a client alone? And this can get a little bit convoluted the further into the trenches you get, the further into the weeds you get with this logic. And so if you can at all, divide things up into a different relationship, having a server that handles all the server logic for you, and then handing a client that renders all the stuff that needs to happen on each client. I highly recommend going that route, as it will save you a lot of work, and it'll just make more sense. Kind of a do as I say, not as I do situation, particularly if you're trying to make this big game where lots of people are connecting, rather than just this client-to-client relationship that we're having here. So you might notice some funky things, and I'll point them out as we're doing them. A couple of Band-Aid solutions or duct tape that I've put on there to make it work. But we'll get there, and I'm hoping that the knowledge that we'll gain through this series will be helpful to you in continuing to create your own card game and learn more about C# programming and Unity. Great. So what we're going to look at is the first steps of this game called Entromancy Hacker Battles, which is one of my tabletop card games. Entromancy Hacker Battles is a cyberpunk fantasy tabletop card game for 2 to 4 players, and in it, players take the roles of hackers and engage in fast-paced strategic card battles to deploy devastating programs and attempt to overcome each other's security protocols. Basically, we're doing a hacking game, and I'll show you a little bit of where we're going to get to once we've completed these tutorials. And if you want to look at the rules yourself and tinker with them and make your own version of the game, you're more than welcome to. I'll also link that in the description for this video. So what we're looking at is the client alone build of what the game board looks like in my game. Similar to previous videos, I have the client open as a built game, a built Unity game. And then I have the host and client, what basically serves as another client here in the Unity editor. So I'm playing the role of 2 players. What we're going to look like by the end of this series, dealing with all of the game logic in this game, is we're going to have a player area down here, similar to what you've seen. These are where my cards are going to go. We're going to have an opponent area or an enemy area up here, which is where my opponent's cards will go and appear, as we've seen before. And then rather than having in the previous tutorials, we just had one drop zone in the middle, I've created 10 different drop zones because that's what my game requires. In my game, in Intermittent Hacker Battles, when we draw cards, we play them one by one from left to right on our sides of the game board. And what we're doing is we're creating a program. Each of our cards represents a function, just like a function or a method in computer programming. And we're compiling a program by placing them down one by one before we're able to execute them. So when I press initialize here, you can see I have a little bit of text here to denote what's going to happen. And I'll discuss what that means later. When I press initialize here, that's the same as the draw cards button we've been using in previous videos. I'm going to click initialize. That's the first step or the first phase of my game. And in Entromancy Hacker Battles, that means I'm ready to draw the cards that I have in my deck. I click that, and then I draw cards on my screen. And you can see them. I can see them, but I don't see anything on my opponent's screen up here. If I switch over to the other client, we see, just as we've been doing in the previous tutorials, those cards have showed up on my on this screen as the opponent cards, and their backs are to us, so I can't see them from this client. And then from this client, when I hit initialize, then I get my cards, and you'll notice that if I hover over them, I can get a larger version of them so that I can read them. And if I go back to the other client, well, then I see here the what's happened is it has dealt cards in the opponent area or the enemy area. And so now we all have our cards. You'll notice that when I clicked initialize on this screen, it still said initialize until I clicked it on both sides. That means that we're waiting for both players to input that they're ready to go and for them to draw cards. And each player has blue cards, whereas if I look at the enemy cards that are represented on the screen, they're in magenta or purple depiction. That just shows me that when I draw cards, the cards that I see are going to be blue, but the cards that my opponent sees are going to be purple, and vice versa. There's another thing that helpful thing that we see here, and remember, I'm just giving you an overview of all the steps we're going to do so that you know what we're going for, what we're working towards, is that there's this magenta color around one of the drop zones. And same here, although it's on the bottom left here, whereas in the other client, in the host, it's on the top right. In Entromancy Hacker Battles, if you've looked at the rules at all by this time, the way we're going to play is from left to right. I'm going to play a card, and then you're going to play a card, and then we're going to keep going from left to right on my screen and left to right on your screen until we've all played 5 cards, and then we're going to execute. And that just means we're going to tally up all the results, and we're going to keep going until somebody wins the game. Let's take a look at how that works. So when I, as the first player here, it shows me helpfully on my screen, the user interface shows that this is where my first card's going to go. So I'm going to drag and drop it into the drop zone just as we normally would do in a drop zone in the middle of the screen. And then it moves to my opponent's turn and it says, hey, it's time for this person to play. So I go over to this person's screen and I see that, yeah, it's my opponent from this perspective or from your perspective has been that this card has been played, and now it's face up in the drop zone just as we want it, and I can still hover over it. Although it's going off my screen, we'd have to do a little bit of work to make sure that it stays on the screen. We're not going to deal with that right now. And then you can draw a card, drop it in the drop zone, and then it goes to the next person's turn. And if I go back to this screen, well, it's my turn to put in my next card here. So on and so forth until we fill the game board. So that's the way that the general turn order is going to work. We're in the compile step here. This is the compile step of creating our hacking program. And we don't need to look into all of the intricacies of how the game works, as there are 15 unique cards and there's just a lot of different things to deal with. You can tackle that on your own. But I want to take this one card as an example so that we understand what we're trying to do in the game and how we're going to program that into our game logic. When I hover over one of these cards, you'll see that all of them are the same. I've just included one card of different color, just 2 different colors within the deck, so we don't have to deal with too much variation right now. All this card does is it's called ping, and in its description, you gain 2 bit points. All of your opponents lose 1 bit point. and variables earned are 1. The way that Entromancy Hacker Battles works is that you gain a number of variables that are equal to the variables on the card when you play that card. So I've played 2 cards on this screen and I've gotten 2 variables from it. And I see that my opponent has played 2 cards and they have gotten 2 variables. That's because it says variables earned 1 on these cards. The objective of the game is actually not to earn variables. Variables allow you to do other things in the game, like special hacker specializations. What the objective is actually to gain bit points. I want to gain a certain number of bit points to win the game. Let's say 10 bit points to win the game. When you see here, I will when I play this card, I gain 2 bit points and all of my opponents lose bit points. That doesn't happen immediately. That happens after we've played all of our cards and press execute. And there are ways to prevent bit points being accrued and ways to deplete bit points. There's all this strategy that is involved. But the point is that I'm keeping in mind that not all of my my bit points aren't going to change until the end of this stage, at the end of this phase, the compile phase. I'm going to keep going, and you'll see that when I drop this card in the drop zone, player variables has earned, or me as the player, I've earned 3 variables because I played these 3 cards. But in this other screen, in your screen, let's say, you've only earned 2 variables, but you see that I've earned 3 variables on my screen. And then you play a card, and then I play a card, and so on and so forth until the end of the phase. And now we've completed the compile step, or the compile phase of the game. And like I said, there are 14 other different types of cards that allow you to see other cards or switch them around and do all this stuff, but we're not dealing with that. We're just going for the most basic one right here. And we see that the button is changed to say execute. So we're getting ready to move into the execute phase. And when I execute, right now, all it means is that I'm going to add up all of the game logic that has happened here, meaning I'm going to gain all of those these cards that say 2 bit points on them, and my opponent's going to lose 1 bit point for each one of them. So I should gain 10 bit points, and they should lose 5 bit points. And we're making it easy on ourselves by saying that, well, this other person here has played those same cards, so the same thing should happen. So when I click execute, a few things are going to happen. The computer is going to handle all of the logic for me and all of the calculations. So we should see that each player's bit points is equal to 5 because I gained 10 and lost 5, and you gained 10 and lost 5. And then all of these cards are going to go to these yards here that we've prepared for them to go into. So either person can click execute, and when they do, we see that now my player bit points are 5 bit points. I still have 5 variables that I could use in the next round. And then the opponent's bit points are the same. And if I look, all of the cards have neatly gone into these yards. And when I put my mouse over them, I also have a new functionality which displays to me in the middle of my screen all of the cards that are in my yard. And the reason why we do that is that, at least in my game, there are some cards that you want to know which cards were played, and there's a strategy behind that thing. The same as for if I want to know what cards you've played, I can refer to them here. So now that we're done with that compile phase, I can now initialize again, and so can you. And then the UI manager shows me that it's my turn to play. In the actual game, we switch who's playing, or we actually flip a coin, but none of that is important. All I want you to see right now is what the game loop looks like, which is just what we went through, and all of the different functionality that we're going to create by adding to our existing game. Cool. So that's what the very, very basic level of Entromancy Hacker Battles looks like. As you can imagine, and probably as you've worked with in your own games, pen and paper games may seem very simple on the page, even if they have complex mechanics or require some calculations. Implementing them in a digital sense can sometimes be much more complicated than, let's say, making a platformer or a top-down shooter or those types of games. And that's why I think it's really good for us to learn how to make these types of games, because they force us to really work with the game logic, and particularly when we're adding multiplayer functionality, there's so many different things that we can do and so many ways to do them that we can get lost quickly. And working through examples like these can be really helpful in gaining knowledge that we can apply to all aspects of programming. Okay, I'll get off my soapbox, and we'll start working on the game. So I'm going to go ahead and close this this and actually close this window as well because I don't need them anymore. Thank you, Entromancy Hacker Battles, for the example. And we're going to go back to our original screen. This is where we left off in our previous video. Looks pretty simple comparatively, although it is fairly complex, so you should pat yourself on the back for getting this far in the tutorial series. We're going to continue by first, where I like to start sometimes is addressing the user interface of the game. We have a pretty simple one that we drew up here, and it served a purpose for a while, but now we're going to try and make it look like the Entromancy Hacker Battles user interface that we saw in the previous screen. So what I'll do first is I'll just take stock of what we have in this screen. I have a drop zone, I have the player area and the enemy area, these two things up here. I have this background that is kind of a weird width. It's 1501 by 755. I have a canvas that's it's the right width for a 1920 by 1080 resolution screen, which is great. I've got a button on the screen, and then I have in my assets folder, I have the different cards that we've been using, and I also have these scripts that we've been using to handle our functionality so far. So that's great. One thing that we've also noticed that we have a network manager that is handling our mirror networking for us, and because of it, we're able to spawn our player manager prefab, which handles a lot of our game logic for us, as well as is able to spawn these different things here, our card 1 and card 2, our drop zone, our enemy area, player area, and the button. Great. We're going to need to make some changes to all of those, as well as split things out into different scripts just to make them easier for us to understand and have a good perspective for them. But let's start with just tinkering with the game board. The first thing I'm going to look at is, and I must admit that I have some notes back here, so you might notice that I'm just like rattling numbers off without knowing where they're coming from, and that's just, I just have a cheat sheet so that you're able to we're able to just get through this without having to change too much. Right now I have my canvas as a screen space overlay, which is great, and I have a canvas scaler, which is a constant pixel size. What I'm going to do here is I'm going to change the canvas to say scale with screen size. That just means that if I have a different screen, a smaller or a bigger one, I want the game to scale to that size. And that's really helpful for me because then I don't have to think about targeting multiple different platforms or monitors or displays. And I want that reference resolution. You can choose this for yourself, but because of the pixels we'll be using here, it probably would be good to follow along. I'm going to change that to 1920 by 1080. And I don't need to change anything else here. I just need to notice that when I've done that, now the canvas size is a bit bigger than everything else. So I'm going to go to my my background, and I'm going to change this to 1920 by 1080. So now it fits the entire thing. Great. And then I'm going to check out my enemy area up here at the top. And it's not exactly what I need to be. And if you step back a few frames into the previous demo that we just did with Entromancy Hacker Battles, you notice that it's not the right color. So we'll do a few new things with this here. We're going to add, we're going to make some changes to the width. We want this to be 1900 so it fits the whole screen, almost the whole screen. And I'll tell you why we're not doing that. We want it to be 196 in height. And then we want the position to be at the 0 on the x coordinate and 432. That's going to take us almost to the top. And the color we're going to change to black, just to match what we were doing before. So now I can't really see it. And what I'll do here is I'm going to add a new component, which is called an outline. And the outline, I'm going to use this color here. Actually, all I need to do is use this little dropper here, and I can get this color, and that will be my outline color. And you'll notice that the alpha of the outline is set to 128. I want to set it all the way up to 255 so that it's I get the full color of it, not just a semi-transparent version of it. And the effect distance, I want it to be 10 on the x-axis and 10 on the y-axis. That'll give me this nice outline that is it's thick enough that I can really notice it, and it will just look really nice and clean on my screen, just like that. Cool, that's my enemy area. Just making sure I haven't missed anything. Our grid layout group is going to stay pretty much the same. Yep, and it already has a network identity and network transform, which is what I need for it to be rendered on the screen or spawned on the screen by the network manager, which is great. I'm just going to go ahead and do the same with my player area. This thing here, I have basically the same task to do here. I'm going to change the position of it to -432. These are just numbers that I've worked out beforehand. The width is going to be 900, the width of the screen. Height is 196, just shy of taking up the whole screen space there. And I'm going to add an outline. And the effect distance is going to be 10 and 10. And I'm going to use the same color as this. Set the alpha to 255. This is all malleable. You can change all of this as you like. And change the color of this to black. Great. Now I got my player area and my enemy area. Something that I want to notice is that I've actually applied these, and I always do this, and it drives me nuts because sometimes it doesn't work the way you want it to. I've done this to the actual objects in my hierarchy and not the prefabs. That will cause me could cause me some trouble later. So I'm going to go up to overrides and say I want to apply all of these overrides to the prefab, and do the same with my enemy area. Apply all of these overrides to the enemy area prefab. Great. Okay, that's pretty good. What else do I need to do? Well, I need to add a player yard. And there are a few things that we need to duplicate here. And I'm going to start with the player yard just because we're not going to actually use it for a long time, but it's just going to feel nice to have our game board all in place. And so here what I'll do is I'm going to duplicate the player area prefab, and I'm going to call it player yard. I'm going to drag it onto the screen and make sure that it's in the hierarchy here. Okay, can change the name of it. Player yard. And let's see. To my player yard, I need to change some of the things that some of the functionality because of the way that my scripts are going to work. Well, the first thing that I need to do is change the size and the location of it. So actually, let me do this to the prefab. So the location of it is going to be at 737 on the x-axis and -472 on the y-axis. And the width's going to be different. It's going to be 352.5 and 196 for the height. Everything else is going to be pretty much the same. And I also need to add I'm going to need to add a couple of scripts to them, an event trigger that we'll have to handle later because we're not ready to tackle that just yet. And I did this a little bit prematurely, so I'm just going to delete this from the scene. And now I can drag my player yard onto the screen. And it's not where I want to be. I'm just going to redo this thing. Pretty typical. Working with Unity. 472. Okay. I'm not sure why that's not where I want it to be, but we can just eyeball it. So one thing you'll notice that it's actually behind my player area right here. So I'm just going to drag that lower in the hierarchy, and then it'll render higher on the screen. Okay. Just want it to be right flush with the corner there. Probably change my snap settings so this isn't so difficult. Great. That's where I want it to be. And then now I will duplicate this, Control D, and call this one enemy yard, and drag that onto the screen. I want this to be above the enemy area. Change the name so it doesn't look all funky. And I want this to live up here in the corner here. Great. Great. So remembering that, well, we're thinking ahead that we're going to want the network manager to be able to spawn these in the game, and they already have network components attached to them. So I'm going to add them to this list here in my network manager inspector, these two game objects. The player yard and the player, where are we? Enemy yard. Great. Awesome. Now you'll notice that this is already getting a little bit out of hand, all of this stuff that we have here. So I'm going to create a couple folders here to help us keep it a little bit more tidy. This first one is going to be called cards. That's where my card prefabs are going to live. And then I'll create another folder that's called slots. We'll use that in a minute when we start working with our drop zones. And one more here that's called UI. And we're going to drag the background into the UI. We're going to drag the buttons into the UI. Card 1 and card 2 are obviously going in cards. The drop zone will go in slots, even though it is technically a user interface, but that's fine. Enemy area will go in the UI, the enemy yard, the player area, and the player yard. And we'll leave the player manager out here for now because I want to separate that from the other prefabs that I have here. Cool. Let's deal with our drop zone here. Actually, before we get to that, let's deal with the button because we'll make some changes to this one as well. Where's my button? Okay, it's here. So the button is going to have much the same functionality as we've previously worked with, but of course it's going to be a little bit different in that the way that we're going to use it is going to have more functionality than we've had before. So right now it's I'm going to change the position of it to be at 819 and position 0, which is fine. The width and the height are going to stay the same. I'm going to change the color of it to black and give it an outline. Similar to what we've done before. We're going to use this same blue color for the outline. We'll give an effect distance of 5. And let's see, we also need to change the text of it because it's not going to say draw cards anymore. And the way that I do that is I go into, if I'm just looking at the button and I want to change the text of it, I can go to Open Prefab and then go to the text here. And right now it says draw cards. I'm going to start it out at initialize because that's what the game needs, and change the color to this blue color as well. A little bit darker because I think I got the edge of it. Well, good enough. Cool. Great. Go back into my scene, and I'll delete this one from my scene, and actually I'll just drop another one here. And of course, it's just not going to go where I want it to, so I'll have to redo this again. The position X is going to be at 819 and 0. So it's right here in the middle of my screen here where I wanted it. Cool. Great. Now that we've got all that done, it's time to deal with the slots, or the sockets. They're called sockets in Entromancy Hacker Battles, and what we've known so far as our drop zone. So let's make some changes to this thing, and then we'll use that and duplicate it to make all of the other things. The first thing that I want to do is go into my drop zone here, and I'm going to change several of the items that are associated with it so that they can look like those nice little rectangles that we saw in the previous screen. That's going to require quite a few. I'm going to create 10 of them. As you saw, I get to play 5 cards and you get to play 5 cards. So I'm going to create within the main canvas another game object, an empty one, and I'm going to duplicate that. And I'm going to call this, one of them I'm going to call player slots. And the other one I'm going to call enemy slots. That's just, these are just going to serve as a way for us to parent all of these different things that we're about to put on the screen. They're just empty game objects that help us keep our game a little bit more organized. Now, with my drop zone, I'm going to change some of the different things that we've already worked with. For example, the width of it is going to be 120 and 177, similar to our cards. The color is going to be, you can probably guess it, we're going for the cyberpunk black and blue theme. The grid layout group is going to stay the same. The box collider is going to need to be changed because it's now it's a different size. So I'm going to change the box collider size to be pretty similar, just 120 by 177. The grid layout group, as we've seen, is just going to stay the same. It just needs to hold 1 card. I'm going to add an outline that uses the same color as we've done before and has the same effect distance. And that's about it. I'm just making sure that we didn't do anything wrong here. Oh, and I also need to add a layer here that is called slots. We're going to use that for determining how our collision matrix is going to work later, because we're not going to want the cards to collide with each other with the user interface, as we've seen before, but we do want them to collide with these drop zones so that we know when a card is being dropped. Go back to my drop zone prefab, and I've created the layer. Now I have to add it to that layer, to slots. Great. Can delete my drop zone from the scene. And now when I drop a new drop zone into the scene, we see that it's the way that I want it to be. Okay. Deleting this for now, just so we can create a bunch of them. We're going to call this player slot 1. And we're going to duplicate that 4 times. Well, let's just call it, let's do 4 times. 3, 4, and so now we have player slot 2, 3, 4, 5 that they have, Unity has done that for me. When I duplicate it the next time, I'm going to change this one to enemy slot 1, and then duplicate that 4 times. Okay, I've got all my player slots here and enemy slots. And now I'm going to parent them under my player slots and enemy slots here. I've got my player slot 1, 2, and you notice if you haven't done this before, you're dragging this right, not in between, but right onto the player slots game object, and that will parent it in the next available space. It will make it a child of that game object. And then I can now collapse this, and I don't have to look at it anymore, and I'll do the same with enemy slots. Feel free to play your own waiting music as you're doing this yourself. I know it can be a little boring, but you know, such is the price of detail in game development. So great. So I have all of these stacked on top of one another. I'm going to change the positions. You can drag and drop to your heart's content. I've just worked this out previously and done the work for us. So the first one is going to be at negative 825 and negative 174. The second one is going to be at negative 505 and negative 174. The next one is negative 185, negative 174. And you're going to have to do this with your own game. Really kind of like take out the mental ruler and see where everything's supposed to go. Let's see. Where are we? Number 4, we're going to do 135 and negative 174. And player slot 5 is going to be at 455 and negative 174. Great. Looking good. Okay, enemy slot 1. Well, that's not in the right place, is it? No. It needs to go where? Well, this is going to be a weird one, but the way that I'm going to set this up, just cognitively, like from my own mind, is to put these backwards so that I remember I'm going from 1 to 5 on the player side, but from 5 to 1 on the opponent side. So this is 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So if I'm working from left to right, I'm actually going to do this backwards. I'm going to go 5, 4, 3, 2, and 1. It doesn't really matter, but for me, it helps me keep track of things a bit better. There's so many things to keep track of with this multiplayer type of game. So enemy slot 5 is going to go at negative 825 and 166. Number 4 is going to be at 505, negative 505 and 166. Three, we're looking at negative 185 and 166. Oops, I just did the wrong thing. I didn't click on this. Negative 185 and 166. What you can't see off screen is I have this whole laptop set up with the whole game that I'm just trying to copy everything over so that you can go step by step with me rather than me just say, okay, do the thing and, you know, come back later. 135 and 166 is where enemy slot 2 goes, and then enemy slot 1 brings us home with 455 on the x-axis and 166 for the y-axis. Great. I'm kind of noticing that the outline here for each of them, I forgot to run these up, the alpha up to 255. I'm not really concerned about that. You can do that on your own time, but that's why they don't look as pretty as they did before, but you know, it's fine. Great. So we've got all of these done. The only thing we need to remember is that these are going to be spawned by the network manager. We want the network manager to handle them. So we need to create 10 areas here. Four, 5, 6, 7, 8, 9, 10. And let mirror know that we want it to be able to spawn our player slot 1, 2, 3, 4, 5, and we'll do the same with the enemy slots. If you're this far in the video series, you've probably noticed that we're pretty methodical about everything that we do, and we do it all together. And if for some reason this part is boring to you, I would wonder about what your game development process looks like, because very much, I mean, I think part of it being a game developer or a programmer is doing all of the menial tasks that make up something that looks looks nice and is playable and works. But also there's so much refactoring and editing and bug fixing and etc. That's like you gotta love what you do, right? So there we are. Great. We have a pretty functional game board here. The only thing we're missing here is the text area, the text that we need to create. And these can be pretty simple. I'm just going to create 2 types of text that are called player text and enemy text. And the way that they both need to live under the main canvas. So I could just right click here and say create a UI, and I want to create text. And this text I'm going to call player text. And let's see, what do we want the text to be? Well, let's see where it's going to live first. We're going to say that it's on the x-axis, it'll be at 750. On the y-axis, it'll be at -114. We want it to be 315 width and let's say 80 height. And the text is going to say player BP : we're actually going to edit this using our script, so it doesn't really matter what it says right now. It just gives me an idea of how big I need the thing to be. And player variables. And we're going to change the font size to 30. And the color, you guessed it, to this nice, what do I need? I need the dropper. To this nice blue color here. Great. Okay. And now I need to duplicate that. I'll call it enemy text. And my enemy text is going to have a position on the x-axis is 750, but the y-axis is going to be 103, so it's here at the top of the screen like this. Everything else is the same, except I'm just going to change this to say opponent BP and opponent variables. I do recognize that I have been switching between opponent and enemy. We probably should consolidate that, but for now it's okay. Great. And that is a pretty good looking game board. It's similar, you know, I've kind of mucked with the alpha here, and maybe in between videos I'll go back and make sure that each one of these has an alpha of 255, but just not willing to deal with it right now. Cool. We have our game board. So let's just see what happens when we play the game, having changed all this stuff and not really done much else. So I press play. I choose to play as the host. It renders everything on the screen. I click initialize, and hey, I get a bunch of cards, so that's still working. It's now dealing me purple cards as well as blue cards, which is not what I want. I want all of my cards to be blue, all of the opponent's cards to be magenta, but that's okay. And then when I drag and drop, I can drag and drop cards still. Great. Just initialize again and again, and just keep dragging and dropping cards, and great. Awesome. So that's, I mean, it's kind of working, right? Like we have the host side working. Let's hit Control B and build a version of the game and see what it looks like when we play with 2 players, just to get a sense of where we're at and where we need to go. What are the changes we need to make? I'm totally going to go in. I don't know what I'm saying. I'm so OCD. I'm totally going to go in and make sure that all of the alphas are done correctly. Let's say that this person is the host first. Yeah, that's going to drive me nuts. and this person is going to be the client. So now they've connected over the local host. When I initialize here, then I see on your screen that it is all the cards backs, I'm seeing them, and vice versa. And now you can draw a card. I can draw a card here and drop it here. You can drop it in, I can drop it in any of the sockets. So that part of it at least is working. What we need to think through here is adding the game logic to how this game is supposed to work. First of all, the first thing I see is that when I do anything, I'm not seeing anything happening here in the text. So I need to say what happens when I gain variables or bit points, and that's going to require special functionality for each of my cards. So okay, let's just bookmark that. I need to change the button so that it says initialize, but that's just a static thing. I need to be able to change the button depending on what's happening in the game. I need to change the logic and flow of the game loop to say that, well, I should be able to draw cards and drop them, but I should only be able to drop them one at a time from left to right, and we have to take turns in doing so. I'm able to see my own cards, which is great, but I want to be able to have a uniform color of cards. So I have, let's say when I play cards, I have a blue deck of cards, and when you play cards, you see them as blue, but I see them as pink. And then I need to be able to tally all this stuff at the end of a round and make it all go into the respective yards. Okay, so that just means I have a lot of work to do, and that's fine. Let's take a look at how we're going to manage all of that. So our first step, well, you could tackle any of those in turn, but there's some logical ways to go about them, and I want to attempt to do the most logical way, at least the logical, well, the way that seems most logical to me. And the first thing I'm going to do here is I'm going to split things up into different folders just to have peace of mind that I've separated certain things into different areas. I'm going to create a folder that's called Card Scripts. I'm going to move my card flipper into that folder. I'm going to move my card zoom into that folder. My drag and drop script into that folder. And then I'll add another folder, and I'm going to call this Game Scripts. And I'll drag the rest of these into that folder just to kind of like separate things in my mind. Great. I also need to go into my prefabs folder and look at my card. I have this card 1 and card 2. If I look at them, my card 1 has this card that's called ping. My card 2 has a ping, and it is magenta. Great. Well, I actually don't want to deal with this. So we did that for our previous example, but in my mind, it's actually going to be more beneficial for me to just have one card that I'm able to use for this ping card. So whether it has in my game, remember, in your game it might be different, but in my game, it doesn't really matter whether I have a purple card or a blue card. That doesn't matter to me. The functionality is the same. When you get a ping, when you play it, you get one variable. At the end of the compile phase, you get 2 bit points, and your opponents lose 1 bit point. So I'm going to delete card 2, and if I had a different card of a different name, I would use that. I'm not going to use it in this example. So I'm just going to have my card 1. I'm going to rename it ping. It's going to require some changes on my part, but that's okay. And even though I've renamed it, I don't need to do much else with it just yet, but I will need to in just a second. I just want to make sure that I have everything here that I need. It looks pretty good. And if I go back to my hierarchy and look at my network manager, I'll see that it's helpfully renamed my card 1 prefab to ping, so I don't have to worry about it there. But I do have it in my script my player manager script. So let's open that one as our first point of entry in editing our scripts to make sense for our game logic. That's in my game scripts folder. And I'm going to go into my player manager. Okay, we'll recall the player manager as being the place where in our previous tutorials we've actually handled most of the game logic in this script. There's been quite a bit more work that we've done since then on the user interface side of it, so we're going to have to add a lot to this. But right now it's doing the job. We're going to call this. We're going to first start by calling this public game object ping. And we're going to delete card 2 from here. That's going to throw us a bunch of errors. And so when we say, well, let me just review this for you here, even though I hope that you've watched the previous videos. We've declared all of our game objects that we want to find throughout the game here. We've added a new list called cards that basically just when the server starts adds our cards into it, and we're able to then when somebody hits the initialize button, or what we used to call the draw cards button, we call a command, which is something that we want our server to do, command deal cards, and that just runs a loop that for 5 increments we want we want Unity to instantiate a random card from that list, which now is just going to be 1 card, and we want the network server to spawn that card and give the authority to the connection to whatever client is owning that. We'll talk about authority again in a minute. We'll do a little review. And then we call an RPC show card function, which is RPC means remote procedure call. That just says that whereas a command is something you want the server to do, excuse me, an RPC is something that you want all of the clients to do. And this RPC show card just says that if the card type is dealt, the card has been dealt, and if we have authority over it, set the transform of the card, set the parent of it to the player area. If we don't have authority over it, set it to the enemy area. If it's our card, show it in my player area. If it's not my card, show it in the enemy area, and get the card flipper script. You'll remember we attached a script to it that is called card flipper, and flip the card so we look at the sprite that's on the back, the back side of the card, the one that says Enter Manzi Hacker Battles, so we can't see the front of it. We also said that if the type of the card is that it's being played, we'll set it to the drop zone. And if we don't have the authority, flip that card so now we can see the front of it. All of this we covered in the previous tutorial. All we need to do right now is just delete this line that we want to add card 2, and we want to add this ping game object. If we go back into our player manager here, the actual prefab, we'll see that it no longer knows what ping is. This used to be card 1. So we need to go into our cards folder and drag the ping prefab so that the player manager can instantiate the ping prefab. Although the network manager is what's going to be spawning it on everybody's screen. Okay, great. Now, there are a few more other things that we need to do here, because now we need the player manager to be able to determine for us which of the slots or the sockets that our cards are able to be played into. So we have player slot 1, 2, 3, 4, 5, and enemy slot 1, 2, 3, 4, 5, and we need to determine where those cards, first of all, where we're able to play those cards when it's our turn, and where the cards appear in these enemy slots when it's the enemy's turn or the opponent's turn. So after declaring all of these public game objects, I'm going to do the same with my player slots and enemy slots. I'm going to say public game object player slot 1. And I'm just going to copy and paste this 4 times, as it'll be a little bit easier. Change these to 2, 3, 4, and 5. You know what? What the heck? I'll paste it again, and I'll call this one enemy slot 1. And do that a few more times so that I'm able to declare 2, 3, 4, and 5. Unlike ping, which is just as a static card, that's not going to change, and I'm going to instantiate that when someone clicks the button. Player slot 1 through 5 and enemy slot 1 through 5 are similar to the player area, enemy area, and drop zone, in that I want the network manager to instantiate them or to spawn them at runtime when the game starts. So it does me no good to drag the prefabs of those objects onto this script. Instead, I need the game to find them when the game has started, when the server has spun up everything that that needs to happen. So what I'll do here is in this function here that's called public override void on start client. We said do what this is a mirror function. Do whatever the onStart client base function does, and then find me the player area, enemy area, and drop zone. And you'll note that I have in quotations as a string here, player area. That's because my player area is literally called player area. So whatever your player area is called, you'll have to call it that in the script. And here, instead of the drop zone, in fact, I can delete this drop zone. I don't need it anymore. We talked a little about this sync variable. Let's get back to that. I'm going to say, make a little space and call it player slot 1 is equal to GameObject.find in quotation marks player slot 1. Copy, and you know it. Paste them all. Change these to 2, 3, 4, and 5. 2, 3, 4, and 5. And then enemy slot 1 is equal to GameObject.find, guessed it, enemy slot 1. And let's keep going. 2, 3, 4, and 5. I live in constant fear that I'll do one of these wrong, like I'll leave one as slot 1 and not be able to figure out the problem, and you'll be watching and just like yelling at the screen that you know exactly what I've done wrong, and I'm just like puzzling through it all, but what can you do? Great. And then let's also do the same with our yards, and let's create a public game object called public game object player yard and public game object enemy yard. And then let's put this right under here. Okay, just collect the UI in different areas. We'll have the player yard equal to GameObject.find player yard. Will be spawned by the network server, and then enemy yard equal to GameObject.find enemy yard. Great. Okay. Now, it's going to be a little bit tedious for me to have, when I start the game, when I run the game, it's going to be a little bit tedious for me to have to write logic that says like, okay, put one card here and then put the other card here and then display it here and so on and so forth. I need a way of maybe abstracting a little bit, or just collating all of that information and putting it all in one place so that it's easier for me to deal with. And the easiest way that I've found to deal with this is just to create a list. And I'll call this list a public list that takes the type of a game object. I'm going to call it player sockets. We could call it player slots, but live a little. That's a new list that takes a game object. And a public list that takes a game object called enemy sockets is equal to a new list that takes a game object. And I want these to be public because I need to access them from other scripts, as we'll see. Great. We'll see, what else do I have? I have a private list. In fact, just for convention's sake, we'll call this a private list game object, which is our cards list. And then in my onStart client, we'll say player sockets dot add player slot 1. Or we need to wait for these players. We can't do this before runtime because we want to know we need the slots or the sockets to be spawned by the network server, and then we can add them to this list. And we'll do that 4 more times so that we add to this list 2, 3, 4, and 5. And then enemy sockets dot add enemy slot 1. Two, 3, 4, 5. Great. Cool. And then just a little tidbit here. We want to, we're going to need to determine at some point, unless your card is just like this willy-nilly free-for-all game where everybody just throws cards at the screen, we're going to need to determine at some point who goes first and who goes second. There are a lot of different ways to do this. Probably the ideal way is to have a random number generator that determines when a client connects to the server, who's going to be the person who plays first, and then we switch in between turns or in between rounds or however your game works. That's also going to have us work probably with the client IDs of the actual player managers or network managers that connect to the network. And we're not going to deal with that in this tutorial. So we're just going to make it as simple as possible. We're going to say, we're going to create a Boolean up here, a public Boolean is my turn. And we're going to equal that to false at the beginning of the game. And we'll say that when the client starts, right at the end of all these lists, we're going to say if is client only, which is a unity, not a unity, a mirror Boolean that we're able to use because we're deriving from network behavior instead of mono behavior, and we're using the mirror namespace as we've done in previous videos. We say if is client only is my turn is equal to true. That just says that remember, we have one version of the game, either the editor or the built version of the game is running as a client only. The other one's running as a host. That means it's a server and a client. So in mirror, you can have is client only, is client, and is server, or is server only, or there's a number of different ones. You can look at the documentation. In this case, we have a host, and we have that acts as a server and a client, and we also have a client that's a client only. We're saying if it's a client only, let's just say that I start first, just to make it easy on ourselves. And then we still have only the server, which is denoted by this tag up here that says the server does this function. When the server starts, add the ping card to our cards list. Great. There's one more thing that I want to go over before we dive into the rest of the code, and that's this sync. Well, it's really two things. It's a sync variable up here, and the way that we're going to handle what's called authority in the game. As you remember at the end of the previous video, we talked about sync variables being something that you want to be synced across the network. So if we were playing like an MMO or a multiplayer game that has avatars, and I wanted to be able to see your health all the time. I could create a health variable, or in our case, a bit point variable that showed me how many hit points or bit points or whatever health you have at all time, and I want the network to just sync that across all clients. In developing this prototype, we can say, or this demo of this card game, I haven't really found them to be all that much useful for our purposes. Your mileage might totally vary, and you might hate what I'm going to do here in this this tutorial. I guess it doesn't really matter all that much. You can look into sync variables by checking out the Mirror documentation and use them at, to your own pleasure. For me, they haven't really been useful in the way that I'm making this game. So just know that it is an option there if you want it. I just haven't had a good way to implement them in this version of the game. So I'm going to go ahead and delete this line here. And we're going to just do a little refresher on authority, because that's going to play into a lot of the things that we are going to do. We're going to say that when I have a host and a server-client relationship, the way that Mirror works is that if when it spawns something, when it spawns an object on a client's behalf, we're telling it, where do we tell it to do that? Here in the network server spawn function, we say we want you to instantiate this card, the server to instantiate the card as you usually do in Unity, and the network server, we want it to spawn that card on the network for everybody to see, but make the authority relate to its connection to the client that it's spawning on. And authority is very important because it says who has the ability to do certain things with that card. If I have the authority in my client, and I'm the client only, then the client that is working as the host does not have authority of that client. That's how we've been able to render it differently down here in our RPC show card, where we've said, if I have authority to that card, well, that must mean that I own that card. That's my card. Put it in my player area. But if I don't have authority for that card, then put it in the enemy area and flip it so that I can't see it. That's essentially how we're using the logic there of has authority, which is another Boolean provided by Mirror. So just to give you a refresher of that, because we're going to use that quite a bit. And we deleted this int cards played as a sync variable. So I'm just going to declare that again up here as a public int cards played equals 0. And we'll just say that we'll handle the logic of how to update that rather than having Mirror do it for us. One other thing that we were going to want to keep track of, and I realize we haven't really played the game much yet, other than setting all this up. That's kind of the benefit of working through how to make something work, and then now I'm able to share with you without having to kind of like tinker around and be like, well, where should this live? I've got this all working, so trying to explain each of these steps to you without necessarily breaking the thing and having to fix it on screen. And also some of the ways that we're doing these things, like the game simply just won't work right now if we try and play it. As you notice, we might be getting errors thrown, or we've deleted the drop zone from different places. So we're going to need to fix some of that stuff before it's up and running again. But I do have my bit points and my variables that I need to keep track of. So I'm quickly getting to the point where I'm running out of space in this script. I mean, I could make this script be 1,000 lines long, but I'm going to need to start thinking about how to compartmentalize some of this stuff, and we'll get into that in just a moment. The next place where I have is this command deal cards area, which is basically just about where I want to get to with this part of the script before we start adding new scripts to it. But I just want you to see that we have this, remind you that we have this command deal cards function, which is a command being run by the server. And where we call that is in this other script that we have. in our game scripts in the draw cards script. This is kind of a misnomer because now we're going to do more than just draw cards, but that's okay. We have a public player manager, which is when somebody clicks the button, it's going to use our network identity to find the player manager and run the player manager command deal cards. Great. What I'm missing here is, well, a lot of different things, but what I'm missing is something that is going to handle the bulk of my game logic for me. Conceptually, I think you can kind of see that what we're doing with the player manager is we're saying, what would a player do? What would the player's responsibility be to do? So, like, a player is going to be dealing the cards, it's going to be shuffling them, it's going to be putting them in one by one in different sockets or slots. But we want the game to handle all of the logic for us and the different components of how the game loop should work. So what we're going to do, we're going to create what's called a game manager. And there's a few different ways of doing that. The simplest way is we're just going to create a new empty prefab object here. We're going to call it game manager. And then I'm going to add a new script here, which is called game manager, and add a network transform so that we can have this be spawned by the network manager when the game starts. And then I'm going to find that script, put it in my scripts directory, put it in my game scripts directory just to keep it all organized. I'm going to open my prefab directory, drag the game manager onto it, and I'm going to get an error here if we look at the console that says, we're trying to replace or create a prefab from the instance game manager that contains the script game manager, which does not derive from mono behavior. This is not allowed. Please change the script to derive from mono behavior or remove it from the game object. Now, if you receive this error, and are not watching this video, you probably have torn your hair out like I have, trying to figure out what this means or what the issue is. And it actually has nothing to do with what Unity, the error that Unity is throwing. What it has to do with is that we haven't resolved the other errors that we've seen in our game. If we go back to our script here, where we look at our player manager, we have deleted a few things. And if we look at cards played, and we wanted to debug, we want to log to our debug console, cards played. We have an issue there. And then we renamed the drop zone. Now we're actually dealing with player slots, and we haven't resolved that there. So I'm just going to change this to player slot 1 for now. And just to resolve those errors. Does player slot 1? Oh, I haven't spelled it correctly. Okay. Now, when I resolve those errors, hopefully the scripts will compile, and we can try it again. Drag my game manager here, and it works just fine. So we have this error in our console that has nothing to do with what it says it is. It's just that we didn't resolve those other errors. So if you've run across that, I'm sorry that has happened to you, because it's really super annoying and it makes no sense. But we're all doing our best, aren't we? Including Unity. When I go to, now that I've created a prefab of it, I can go to my network manager and make sure that I drag this game manager into the spawnable prefab so that it can do that for me. Now I can get back to work. So I'm going to go into this new handy dandy game manager script, and it's got nothing in it. I got to make sure that it derives from mirror, or that it uses the mirror namespace, and now that the script itself derives from network behavior. And well, let's think about a few things that we want this game manager to do for us. we want it to handle the basic game logic that we have in Entromancy Hacker Battles, which means that it needs to take care of 3 different phases of play, at least 3 different phases of play. It needs to handle the initialize phase, which, as you remember, when I hit initialize and my opponent hits initialize, that's going to draw cards for us. It needs to handle the compile phase, which means that it needs to let the game know when we're putting down cards and when we should be able to do that. And it needs to handle the execute phase, which means when we click a button, it should tally up all of the bit points for us and move all the cards, wherever it needs to. It doesn't actually need to do the act of moving those cards. We'll have the player manager to do that, but it needs to handle the game logic of when that should happen. So we're going to approach this by keeping track of a few things in some variables here. At the top of this, I can delete this comment. At the top of the script, I'm going to create a public integer called turn order and make that equal to 0. How many turns have happened? In general, there are going to be 10 turns per round or per compile phase, because I'm going to play 5 cards, you're going to play 5 cards, and of course we're going to alternate. We're going to start at 0. We're going to say there's a public string. We're going to call it game state, the state of the game. And we're going to begin it, we're going to initialize it at initialize. The game starts in the initialize phase. We're going to keep track of a public integer called player BP, player bit points. We're going to make that equal to 0. We're going to have a public integer opponent BP, make that equal to 0. And we're going to do the same for public integer player variables and an integer called opponent variables. Those are going to be equal to 0. When I look at my screen, I have this player BP and player variables and opponent BP and opponent variables. That's where these different pieces of text are going to derive from the game manager, which is going to tell them exactly what those numbers should be. And we also want to notice that these numbers are going to be different on my, they're going to be reversed on my client versus your client. So if I'm playing as the host, for example, then my player bit points and variables will be on your screen, they'll be the opponent bit points and variables, versus on your screen, your bit points and variables will be my opponent bit points and opponent variables. We'll see how that works in practice in just a moment. I don't need to do anything in the start menu, you can tell games are on my mind, in the start function just yet. So I will just leave that there, and I won't need the update function or method for this particular script. What I do want to do is create a place where I can create a method where perhaps other places in my game, other scripts, perhaps my player manager can change the game state. And what usually what you could do is make the game state private, and then only certain functions could or methods could change that game state. That's kind of how you handle like a closure in computer programming. But I don't. I actually need to use the game state elsewhere. So I'm just going to create a function where I can change the game state from elsewhere, and I'm going to call this public void change game state, and it's going to take one parameter that's a string called state request, and I'm going to say if state request is equal to, or double equals, is equal to initialize, the string that we already have here, do something, else if state request is double equals to compile, do something else, else if state request double equals to execute, want to go to the execute phase, well, do something that is helpful for the execute phase. Great. Where do we call this from? Well, the most sensible way for us to call this is from the draw cards script, so that when somebody, unlike other games where the state of the game might change just automatically, or if like you have an AI or something, we'll take a look at that at some point in a later video. We want to be able to change the game state when somebody clicks these buttons. And at specific points, remember, we don't want to just change from the compile to the execute phase when I've only played half of my cards and you've only played one of your cards. We wanted to do it after we've all played 5 cards. So we'll take a look at what the draw card script should look like. We already have that open. And in my draw card script, I need to add a public game manager called game manager. And I'm actually, you'll notice I'm not saying a public game object. I actually just want the script called game manager. And in the start function or method, I want to say the game manager is equal to game object dot find game manager. Find that game object called game object, get component, game manager. This is Unity's way of saying, in my hierarchy, find the game object called game manager, and then get the component attached to it that's called game manager. And that, you'll get a type error if you don't do it this way, because we're looking for a script or a class called game manager, and we want to make sure that we're getting the component attached to a game object that's called game manager, which also happens to be called game manager. If you didn't say the get component part, it would give you it would throw you an error saying that you're not getting the right type, or it cannot convert your game object into a type of game manager. And then in the onClick method, we need to separate some of this stuff. So we still want to find the player manager, but we don't necessarily want to do just command deal cards anytime somebody clicks the button, as we were seeing before. We want to say if game manager dot game state is equal to initialize, then do a thing. Maybe we'll want to deal those cards. Else if game manager dot game state is equal to execute, do a thing. I know it may be a little bit tough to follow along if you're not an expert on how my game works. And of course I am, so it's a little bit easier for me to just like talk through this stuff. So let's just think about how when I play the game, and I'm not sure that it'll actually work, but we can try. When I host a game and I press initialize, oh good, it still works. That's what I want to happen. I want I wanted to instantiate or spawn cards for me. And then when my opponent does the same, I want it to move into the compile phase where I'm able to drag and drop cards into their respective places. And I don't want this button to work anymore during that time. I want it to just say compile on it and let me know I'm in the compile phase. And I don't have to use it at all while I'm dragging those cards about. When I need to use it is when I want to execute. When I want all cards to be tallied up and to be put into their respective yards. So basically I don't want the button to have any functionality during the compile phase. So here I only need an if statement that says if the game state is initialize, I want the button to work in a certain way. Or if the game state is execute, I want it to work in a certain way. I don't need a compile step here because I don't use the button during that step. And then just to make things a bit more neat, I'm going to create a couple of private methods here. One's called void initialize click and one called execute click, and they'll handle the game logic of what I want to happen when the button is clicked. In the initialize click function, or method, I'm gonna put this player manager command deal cards, and I'm gonna say if the game manager's game state is equal to initialize, then do player manager, oh, no, I'm sorry, then do initialize click. Else, if the game state is execute, do execute click. And we haven't determined what execute click is going to look like yet. All we know is that when it's initialized click, we'll do player manager command deal cards. This allows us to add other functionality here in the initialize click area of the script. We're actually going to come back to this, but let's take a look at what the command deal cards. We'll just kind of like peel the onion back. Now we know that when if the game manager state, the game state is initialized, which it is at the start of the game, we in our draw card script, when someone presses the button, it should do initialize click, which then kind of waterfalls down to command deal cards. We want to run a command on the server to deal cards. Great. Now I go into my player manager script and I take a look at my command deal cards. Right now it just instantiates 5 random cards and it spawns them on the network server and assigns the authority and the connection to the client, and then asks each client to show the card based on their authority. Cool. Well, we need to add a few things here for it to work the way that Hacker Battles works. And the first thing is that this all looks, pretty good. I don't need to change anything here, but I want to change the game state after the cards are dealt. You'll recall that when I play when I initialize, when I deal cards to myself, and then you deal cards to yourself, after both of those things happen, I want the game state to change to the compile phase, allowing us to deal cards or to place cards one after another from left to right on our board. So I'm going to create a new function here that's called RPC GM change state, and it's going to take a string called state request as a parameter. Actually, we'll just call it compile because I haven't created the function yet. RPC GM change state, that for me is just shorthand for saying game manager change state, change the game state in the game manager. And you'll remember that the remote procedure call is something that we want all clients to do, whereas a command is something that we want the server to do. Now I need to declare what this function actually does down here under all these other commands and client RPCs. You'll also recall that before writing a command or a client RPC, I have to tag it as such. So I'll say client RPC, and in mirror I have to begin the name of my function as RPC or CMD if it's a command. What do we call it? RPC GM change state, and it takes a string called state request. And we're going to say that we want to access our game manager and say game manager dot change game state based on the state request. Great. We're getting an error here because we haven't actually declared what our game manager is. So let's go back up here to the top of our script. And we have, let's just put it right actually at the top. Why not? Right above ping. because this is an important thing. We want it to be right at the top, like it matters. Public game manager. Game manager. We'll do the same thing we did in the draw card script, where at the beginning of the game, when the client starts, we're going to say the game manager should be equal to game object dot find game manager, find the game manager in my scene, and get the component game manager script attached to it. Okay, and that should all resolve just fine. Yeah. Now when we call after dealing cards, we want to change the game state to compile. But we have one problem here. The way that we've written this, if I look at the waterfall, is that I've said, all right, I've got my game manager. When somebody clicks the button, it'll run command deal cards inside this initialize click function from the button. And then it will immediately run the remote procedure call for both clients to change the game state to compile. And when it does that, it runs this little remote procedure call, which in my local client, it's going to go to my game manager, and it's going to change the game state based on my state request, which is compile. And then we'll do stuff there. But that's a little bit problematic because that means that when one person clicks it, we're going into the next phase of the game, which is not the functionality we want. What we want is for me to click it, then for you to click it, and then for the game to start, or for the compile phase to start. So we have to add a tiny bit of logic to make for that to make sense for us and for the game. So what we'll do is we'll go, we're already in our game manager script, and we're going to add a little private integer up here called ready clicks. Make that equal to 0. And just saying, like, are we ready to play? Well, 0 people are ready to play. And we'll say in the change game state section here, we'll say if the state request is equal to initialize, let's make sure that ready clicks is equal to 0. That's when we go from one compile and execute phase to the next. So basically, after we've completed one game loop, just set the ready clicks to be equal to 0. And also set the game state to initialize. The game starts out that way, but it's not going to be like that all the time. After we play through one round of play, it's going to have to go back to initialize. So if the request is to change the game state to initialize, well, go ahead and do that. Else, if the state request is to compile, well, let's not be hasty here. Let's make sure that ready clicks, that everybody's ready to do it. So when let's say I click the button first and I say, okay, go ahead, initialize click, that's going to have one ready click. Then the next person that does it, let's say it's you and your client, you can say, it will say, that's my second ready click. So I want to say that if this is a 2-player game, which it is, then if ready clicks is equal to 1, then you can change the game state to compile. Essentially, when I get the request of compile, if somebody else has already, well, meaning me, has already clicked on the button to initialize and gotten their cards, then you can go ahead and change it to the compile phase, and we'll handle that. Finally, in my game state request, if for execute, I'm going to say game state equals execute. If I get a request to change the game state to execute, go ahead and do that thing. Great. Okay, cool. We're in pretty good shape here. We still need to add a few things to get this game up and running, but we're doing pretty well. Awesome. So let's continue down the list of things that we need to change in our player manager. We've already shown how we can change the game state in our game. we have this public void play card that is called when a card is played. And the fun thing about this is we're going to start to get into like what are the actual abilities of those cards when they're played. We're not going to do that right now just because we have other things to do before we get there, but we can delete these cards played ++ and debug log. We'll handle these in a different fashion. Right now we just need this command to play a card. And we'll recall that when a card is played, we run this command. When I play a card, we run this command on the server that essentially just is a way of getting each client to show the card based on the logic of who has the authority. Right now, we have it said that in the RPC show card, the remote procedure call to show each card, we say that if the type of the card is that they were just dealt, which we say in this RPC call up here in command deal cards, if I have authority of the card, I'm going to set the transform, set the parent of the transform to my player area. If I don't have authority, then set it to the enemy area and flip the card. Let's deal a little bit with how this logic is going to be handled so that we can do a couple of things. You'll recall that when I deal cards to myself, actually I'm not sure, yeah, it should still work actually. I haven't changed enough of it yet. I want my cards to be dealt to me to be blue, but the cards that are dealt to my opponent to be pink. And I want to be able to play them only in the sockets that are left to right on my screen, depending on whether it's my turn or your turn. And all we know at this moment in regards to that is that it's my turn if I'm the client. I start out with it being my turn. We need to open up another script to do that. We need to open our, go into our card scripts folder and get into our drag drop folder. And we might also need to access our card flipper. I don't recall right at this moment, so we'll just open that to be safe. Okay, just moving this around here so that I have a little bit of organization. Okay, so in the first case, I have my cards that are being dealt, and then in the second case I have my cards that are being played. You'll remember that the cards that are being played are given that notification in the when a card is being dropped. When we end the drag, we say if it's over the drop zone, then set the parent of its transform to the drop zone, and then run the play card function in the player manager. And in the player manager, the play card calls the command to play a card, and the command itself runs an RPC that sets the not the type, but it sends a notification that this card is being played, it's not being dealt. When I go back to my drag drop, my player manager, I see that I have this flip method in my card flipper, and I need to change some of that logic to fit my game. In your game, it might work just as fine the way that we did, where we just had these random colors. But in my game, I need my player cards to be blue and my opponent cards to be purple. So I go to my card flipper and I take a look at what I have written already here. I need to change some of these things so that it makes more sense for how the logic is going to work. It still can derive from mono behavior. I don't need to do any networking things here, but I need to do I need to add a few things. I'm going to say public sprite cyan card front and public sprite cyan card back. Public sprite magenta card front and public sprite magenta card back. And then I'll change these sprites to private sprite card front and private sprite card back. Okay. What we'll do is, now that we've exposed these public sprites, we'll go into our editor and we'll find our card prefab, just ping, and we'll see on the script here, in the card flipper script, we have to make sure that we just comment this out for a second so that we can make sure that the script compiles. Save it. And now that the script is compiled, we'll see that we've exposed these in the editor. Now I go into my assets folder, and if for some reason you don't have these, I'll link them in the description. You should have them from our previous project. I'm going to drag the cyan back to the correct field, the cyan front to the correct field. Same with magenta. So we can use these and edit them all from the safety of this one prefab, of our card prefab. And we'll start this out by saying we'll create a public void set sprite, and we'll say string type as the parameter. And we'll say if the type is equal to cyan, well, I bet you can guess that we want the card front, the private sprite card front, to be equal to the cyan card front, and we want the card back to be cyan card back. Else, if the type is equal to magenta, we want to get the component. Remember, when you say just game object lowercase g, that means the game object that this script is attached to. We want game object get component, the image, this thing here in the inspector, get the image and get the sprite from that image and change it to the magenta card front. So the prefab that we're working with here, ping, automatically has this sprite as its the source image, or the sprite is this cyan thing. If the request is to change it to magenta, then change it to this magenta card front that we exposed in the editor, and we'll say that card front is equal to the magenta card front, and card back is equal to the magenta card back. Great. Now we can add change our flip function, and we can say, we don't need any of this actually. We can just say, oops, deleted too much there. We can just say, if the game object that this script is attached to, get component image dot sprite is equal to card front, then game object dot get component image dot sprite should be equal to the card back. Otherwise, game object dot get component image dot sprite should be equal to the card front. That just means when I want to flip the card, I'm going to check if the sprite attached to it is the card front, let's say the cyan card front, well then change it to the card back. But if it's not, that must mean that it's already on the card back, so switch it to the card front. Then we just have this nice clean card flipper script that allows us to not only handle what sprite should be used, but also how to flip the card. We go back into our player manager script and take a look at it here. And we say, if I have the authority to the card, for the card, then card.getComponent, card flipper, find the card flipper, and use the setSprite function to set it as cyan. If I don't have authority for the card, put it in the enemy area, and card.getComponent, card flipper dot setSprite, and make it magenta. Great. So that's all we need to do for that part of things. You know, I wonder if that's going to work by itself. Let's just take a little break, save everything, build the scene, and see if that works by itself. I have a hunch that it might not. We haven't done enough to move forward, which is one of the tricky things about developing these types of games is you kind of have to get over certain milestones before you're able to actually make it work the way you want to, but you know, it's fine. So I'm going to use this one as the host. This one will be the client. I'm going to use the initialize here. Oh yeah, and it worked. Great. Initialize here, and great. So now I have these cards here, and I have these cards here. My cards are blue, and your cards are also blue, but you see my cards as pink, and I see your cards as pink, which is great. Something I just noticed here, and something that many of you have brought up, other than the size of the font, which I've hopefully increased and you can see better, is that for some reason in the editor, when I hover over cards, I can see a larger version of them, but it doesn't work in the built version. And Calvin P. Streams, one of our viewers, rightfully noticed that it's just an error that I have in one of my scripts here. Might as well take a look at that now if you've been wondering about that. In my card zoom script, I have here, when I hover over a card, I say that set the parent of the card that the new card that you've created as the bigger card, set it to the canvas, and make the don't let it keep its original position, and that's making it false. So I just need to change that to true. Now when I go and build my game, we'll see that it works. Host, client, initialize, and now you can see bigger versions of the cards in both clients. So thanks, Calvin P. Streams, for pointing that out, and that was a helpful little trick for us to use here to make everything work correctly. Okay, now when I drag and drop, we'll see that I've dragged a card from, is this your game or my game? I can't remember. Let's say this is my game. I've dragged it from my game, and it appears in your game sort of correctly. I mean, it's deleted one of these cards up here, so it looks like one card has been played, and it's parented it to a drop zone here, and it's, you know, changed. It's flipped the card, so now you can see what card it is that I played, and you can drop a card here, and it ends up in this initial drop zone, and it does the same here for me. So this doesn't, like, the game doesn't really work, but it is functional in some ways. So now we need to handle the logic of okay, I need to limit which drop zones we can play cards in, and I need to render them on screen appropriately so that when I drop a card in my screen, it shows up here for you, and when you do the same, it does the opposite for me. So we need to do a little bit of work on that. Okay, but things are working pretty well. So let's figure out how exactly to do that. Let's go into our draw cards script. Drag drop script. Our drag drop script knows nothing about our game manager just yet. So at the top of it, we're going to say public game manager. And you might be surprised to see that I'm going to delete this declaration of the drop zone because we're going to have the drop zones handled elsewhere. Is dragging is still false, is over drop zone, all of this stuff is still pretty good. What I need to do here is, instead of finding the drop zone, I need to say game manager, as we've done before, is equal to game object dot find game manager, should be familiar by now, dot get component game manager. Whoops. Game manager. And then what I've done, I think I've done this later, but something I found is in working with Mirror, there can be a little bit of trouble of finding which player manager you're trying to access based on the net code. I've also noticed some issues with the start cycle where, like, if you look through the very helpful videos about mirror networking, or check out the documentation, there's this whole start cycle where you'll go through on start client, then on start authority, on start local player, and then your start functions run. I've found a little bit of finickiness with when things should happen before others and where the player manager is. And so I might be a little bit conservative and not really following the don't repeat yourself principles of usual programming. And the reason why is because I've had to troubleshoot and bug fix a lot to make sure that objects have been instantiated or created or spawned when they should be and when they're needed and all this stuff. So if you notice me repeating myself a couple of times with my code, that's why. It's just because I've run into issues and I haven't been able to find a better solution than that. You might find one, and I'd love to hear them if you're able to do so. So under this code block where we find the game manager in the canvas, I'm going to say network identity, lowercase network identity, is equal to the network client dot connection dot identity. Oops, nope. Connection dot identity. And our player manager here is equal to that network identity. Oops, network identity dot get component player manager. Find the player manager that is attached to my client. I don't need to change anything in my update method. On my collision enter 2D, on my on collision enter 2D, when there is a collision, I once said is over the drop zone is true, and the drop zone is equal to collision.gameObject. Whatever collision is happening, if it's a drop zone, then go ahead and allow it to be, say that it is over a drop zone. This is one of the places where I can change the logic to say that when I drag a card over a drop zone, the way that we handled it originally is that when there's a collision, we're saying, okay, that means it's over the drop zone, make it droppable. Don't let it be droppable anywhere else on screen. So here's where we're going to use our logic to dictate when we should be able to drop a card. And we'll say if collision.gameObject is equal to double equals player manager dot player sockets and player manager dot cards played, then do the thing. Say that it's over the drop zone, and make the drop zone equal to the collision. So the object that is involved in the collision. Let's take a look back at our player manager so we understand why we're doing this. At the top of our player manager script, we have a public integer called cards played, which is set to 0 at the beginning of the game. No cards have been played. We also have a player sockets list that has our 5 player slots, our 5 player sockets, 1, 2, 3, 4, 5, in that order. Remember that when you have a list in C# or when you have an array, for example, the first item in that list is going to be at 0. That's going to be the first number is not 1, it's actually 0. That's the 0 index, if you will. So if cards played is equal to 0, and I want the first slot or in my the first index in my player sockets list. How is a better way of saying this? If my cards played is equal to 0 and the slot in the 0 index of my player sockets is player slot 1, that should mean in my draw card script in my drag drop script, if the collision that is happening, if that's equal to, if the game object that's involved in that collision, if that's equal to player slot 1, which is at the 0 index of my player sockets script, player sockets list, then go ahead. We've had the correct game collision. Otherwise, it's not the correct collision, so don't do anything with it. Similarly, that means that we need to be able to increment our cards played so that the next time there is a collision, it will be player slot 2 that is at the right index of my player socket list, and then player slot 3, player slot 4, so on and so forth. So if we look at our game here, when I press play, we don't actually need the whole thing to work. We can just say that when I have cards, and if it's my turn, then we'll say that anytime this card goes over one of these drop zones, there's going to be a collision. But only when that collision, the game object involved in that collision, is equal, the index of it in our player cards list or player sockets list is equal to the number of cards that have been played on my part of things, should it be able to be droppable. So when we start out, player cards played is equal to 0, and the 0 index of my player sockets list happens to be player slot 1. It's not player slot 2, 3, or 4. So this card won't be droppable here in any of these slots, and enemy slots don't even exist in my in areas which my card can be dropped. So it's going to have to go into this socket or not at all. And then when I increment my cards played, that means it's going to be, after I've played one card, it's going to say cards played equals 1. And my list is going to move to the next index, which is 1. And the number 1 index of the player sockets is actually player slot 2. So that's how we're going to handle that logic. Cool. Awesome. If I move a little bit further down in this script, I don't need to change my collision exit at all. I don't need to change my start drag at all. And my end drag function, I do need to change a little bit here. I have is dragging is equal to false at the end of my at the end of the dragging of my card. When I have it in my is over drop zone, I also want to say if it's over the drop zone, meaning we've handled this logic that we just discussed, and player manager dot is my turn. So if it's over the drop zone and it's my turn, then go ahead and change the parent of the card and handle everything that you need to do. So I'll say transform set parent is draggable equals false, and I don't need to declare all this stuff because I've done it earlier in my script. I can delete that, and I just have player manager.playCard game object. Otherwise, set it back to its start position and set its parent to its start parent transform. What's really fun is that now I have all of the logic in my drag drop script that I need. The thing that we did is that we said that if it's over the correct drop zone, which is we're handling in our player manager script, and it's my turn, go ahead and let the card to be droppable. That's how we handle that piece of it. But we also need to handle the piece where once I do that, you'll recall that when I played a card, it wound up in this drop zone. But when you played a card in your own drop zone, it landed in my same drop zone. So that's not ideal. The way we're going to handle that is go back to our player manager script, and we'll go to the client RPC, which is the show card remote procedure call. And we've already done the dealt section of that. We're looking at the played section. So when the card is played, we have some logic here that's not really usable anymore. So we're going to change this to say if cards played is equal to 5, double equals, make the cards played in my player manager script to be 0. That just means after we've done a full round of cards, just set it back to 0. If I have authority for this card, card.transform set parent player sockets cards played dot transform false. Okay, delete that. If I don't have authority for it, card.transform.setParent enemy sockets. All right, remember, we want our enemy sockets list at the index of cards played dot transform also false. And then flip the card. So we're basically saying here, when a card is played, if the number of cards played on my player manager is equal to 5, that means we've already played one round of play. Set it back to 0. If I have authority over this card, set the parent of its transform to the index equal to the number of cards played and of the player sockets list. So if it's if I have 0 cards played, put it in the 0 index of player sockets, which would be player socket 1. If I don't have authority, do the same thing, but for the that means the card has come from elsewhere. Do the same thing, but put it in the enemy sockets index of 0, and flip it so that I can see the card. And when a card has been played, increment cards played ++ within my script. There's a little bit of funkiness with this. I'll just let you know ahead of time, because I've tried this a couple of different ways, and for some reason when I'm able to work with Mirror to do to just increment cards played, that works just fine here. But I have to say player manager is equal to network client dot connection dot identity dot get component player manager Oh, you know what? I need to rename this because this is going to throw me a bunch of errors. Let's just call it PM. Player manager PM. PM dot is my turn is equal to PM dot is my turn. Exclamation point PM dot is my turn. This is a bit of weirdness. If you tinker with this and find a better solution, I'd love to hear it. Please feel free to post in the comments. But what I'm doing here is that when I run this remote procedure call and a card is played, I want to increment the number of cards played. For some reason, this only works on the card that is being played rather than on every in the client where the card is being played rather than on every client. And I have to use this network client identity get component script to access the player manager attached to whatever client the remote procedure call is being called on, and then say that, like, if it isn't my turn, make it my turn. If it is my turn, say that it's not my turn. And that's how I handle the logic here. It's not the cleanest way of doing things, and I don't love it, but in trying this a bunch of different ways, it's the best way that I've found. So, you know, take that as you will. Cool. So now we know where the cards are going to be played and where they're, and hopefully how to switch between turns. But I want to do one more thing here while we're in this. I want to say if when I have authority for it, I want to also call a command called cmd gm card played. Run a command that's called, for me, this is shorthand for game manager card played. And then we're going to declare what that method is, what that command is down here. We'll start by saying command. Remember, we're calling that if I have authority over that card, and the type is played. When I play a card, run this command gm card played. And all the command gm card played is going to do is going to call a remote procedure call, which is called gm card played. If you've only made single player games before, this might seem like a bit redundant. When we're making this multiplayer thing, you'll find, especially when we're doing this, you know, host client relationship, you'll find you'll be doing this a lot, where you'll want to send a command to the server to tell the clients, all the clients, to do a thing. So below this command, we'll call this, we have to write a client RPC tag, and we'll say void RPC GM card played and all we need to do here is in each client we'll notify the game manager that a card has been played. So we haven't written that function yet, which is a little bit backwards. So let's go in here in our game manager and write it. We'll say public void card played turn order, increment it, and if the turn order is equal to 10 cards have been played, change game state to execute. So pretty simple here. We're just keeping track of a turn order that says in everybody's game manager that says keep track of how many cards have been played. What turn is it on? After there are 10, the 10th card has been played, when turn order is equal to 10, change the game state to execute, which we've seen is in the demo that we provided, is when we're able to click the button and have it do all of our calculations for us and put all the cards in their respective yards. Great. I think that's just about what we need to have a if not fully functional game, pretty close to it. Let's just spin this up and see what we got. So I've hit Control B to bring up a build of my game. Okay, I will play as the host and you will play as the client. And you initialize, I see those cards on my screen. I initialize, you see those cards, great. Now nothing's changed here, but I'm gonna have to mess with this so that I'm only able to click this when during the right time. Like right now I'm able to just keep clicking on it, which isn't great. So we'll have to address that. And then I draw a card here and I try to play. But remember, I'm not the first player here. I'm working as the host and you're the client. So you as the client should have the first turn. So you drag and drop and it goes right in your the first socket. And that appears now in the first socket of my enemy sockets. Remember, I'm playing left to right and you're playing left to right. Now I get to go because it's my turn. And that appears correctly there. Let's see, if I try and drop, if you try and drop a card into one of my sockets, it doesn't work. Or if you try and drop it into your fourth socket, it doesn't work. But when you try and do it in the second one, it works. That's great. And we keep going. We keep going. And again, one more time. All the way. And again. And now we've all played our cards. And nothing's happening. I just can keep instantiating cards. Great. I mean, this is the functionality that we've worked for, and it's totally working. So that's awesome. Let's stop this. Actually, just close this. And let's now figure out what happens when we want to move between phases, and particularly when when we finish a phase of play, a compile phase, when I click execute. We won't handle the card functionality just yet, but we do want it to go into the respective player yards. And that's actually, if you can believe it, relatively simple to do. So in my player manager, what I'm going to do below all this other stuff is add a command that is called public void cmd execute, command execute, and all that's going to do is it's going to call rpc execute. Remember, that's when you click the button you want the game to execute. And this client RPC called void rpc execute, we're going to say, I'm going to create a loop for integer I equals 0. I is less than the number of player sockets dot count. I plus plus. And within this for loop, I'm going to say player sockets at the index of I dot transform dot get child in parentheses 0 dot game object dot transform dot set parent, and in parentheses player yard comma false. That just means that I'm looping through the player sockets list that we've set up for ourselves, and for each element or each item within the player sockets, I'm going to get the first child within it, and each one of them should only have one child. It's the card that has been placed in that socket. I'm going to grab the cards game object and set the parent of its transform to the player yard, actually to the player yard dot transform. And I'm saying false here because I don't want it to keep its world position. I want it to change the world position of the card so that it fits neatly within the player yard grid. I'll do the same down here by saying enemy sockets at the index of I, transform, get child, 0, game object, transform. A lot of chaining here. Set parent, enemy yard, dot transform, comma, false. Great. Cool. So I just need to, now I've created a command to run this execute and this remote procedure call so that it happens on both or all clients. Just need a place to call that, and the most sensible place obviously is the button that we have, the draw cards button that we used when we initialized the game. And so when I go to draw cards, I see that I've already set up this if the game state is execute, which happens when all of our cards have been played and placed in their sockets. We call the execute click function. And in this execute click, similar as we did with the initialize click, I just need to I just need to tell the game what I wanted to do at that point. And in this case, I'm just going to say player manager dot cmd execute. So call that command to run the remote procedure call. I also, at this point, because I know my game, obviously, when we execute, meaning when we put all of the cards into their discard piles, into the yards, and we'll handle also some calculations to determine what those cards do at a later point, I want to reinitialize the game and get it ready for us to draw cards again if nobody's won the game just yet. So I need to change the game state to back to initialize. As you'll recall, there's the initialize, compile, and execute phase. And after we finish with the execute phase, we want to go back to the initialize phase. So I'm going to say player manager dot cmd gm change state, and I want to say initialize. Now I haven't had to call the change game state function remote procedure call from outside of the player manager, so I haven't actually created this function here. You'll remember that we created this RPC GM change state based on string that passes in a string called state request in as a parameter, but we haven't created a command to do that. So let's do that now and say, if we're calling it from outside of the script, it'll be a public void cmd gm change state. We'll take a string called state request, and that's going to call this client RPC that we have just down below, RPC GM change state request. Okay, which in turn calls the game manager change game state. If we take a look at that here, that's change game state. It takes that state request, and if the request is to set it to initialize, set the ready clicks to 0 and change the game state to initialize. If the state request is to compile, well, if the ready clicks is equal to 1, meaning that one person already clicked on the initialize button, then go ahead and change it to compile. That means we're all ready to play. And if the state request is execute, which happens when the 10th card is placed, or when turn order is equal to 10, change the game state to execute. There's a couple of tiny things that we need to do before we can get this to work. The first one is that right now we say that if the state request is to compile, we do this thing to check whether or not ready clicks is equal to 1. That's all well and good, but when we get to the execute phase, we're going to have we need to figure out, first of all, how to handle this ready clicks thing. And we also might have a case where we don't want everybody to click the button. Like when we start the game, we want to be able for me to click the button to draw cards and you to draw cards before we go to the compile phase. But once we finish placing our cards, it really doesn't matter, at least to me, who presses the execute button. Only one person needs to press it, so we don't need this check here. So what we'll do first is we'll go into our player manager and we'll look at the RPC change state function that we have just below the command that we wrote. And we see that when the server receives a change state request, we're just going to handle it by asking our game manager on our local client to do it. Let's just say that if the state request is equal to compile, then in our game manager, change ready clicks. We haven't written that function yet, so let's do that. Back to our game manager. And right under, where does it make the most sense? Let's do it in between our change game state and our card played. We'll say public void change ready clicks, and we'll just init increment ready clicks. So when somebody clicks the button, it'll send a state request and a change state request. And when it does that, the remote procedure call will have each client's game manager increment ready clicks. If ready clicks is equal to 1, somebody's already clicked it, then we'll go ahead and change the game state to compile. But we don't need to do that for the other phases. What we do need to do, just to clean everything up and make sure that everything works once we've finished one round of play and are renewing back to the next round, we need to change just 2 tiny things and say, if the state request is execute, remember we've been incrementing our turn order when a card is played, make the turn order equal back to 0. So we can start fresh in our next round. And in our draw card script, right here when we do our initialize click, this is one of the areas, just a quirk that I've come up with that we mentioned back here in our player manager, where I was having an issue about whether or not cards were, the number of cards played is equal to 0. I have no idea why this is happening, and it could be perhaps solved with a sync variable, but I've tried many different ways to refresh the game so that when we start a new round of play, we've already done our initialize, compile, and execute phases, we're starting a new round. I've tried changing the number of cards played back to 0 in many different places and haven't found a simple and elegant way of doing that that hasn't required me to do a couple of workarounds like we're doing right now. You might find a better solution for this, or your game might not require this at all. So if that happens for you, that's great. But if you're having trouble with it, as I have, what I'm doing here is in the draw cards script, when we click this initialize click at the very beginning of the game and we're asking the player manager to deal cards for us, I just say player manager dot cards played is equal to 0. This combination of things has worked for me. Otherwise, there's been some hiccups, even if I debug to the console log. Even if I log to the debug console, what is cards played at any point in time. So it's not super elegant, and I don't quite like changing a variable or an integer within one script from another script. We really should wrap this in a function as we just did with ready clicks. But it is cost of doing business, I suppose. One has to just try different things until they work, and this has worked for me. Save everything. And actually, before we build the game and play it, I'm going to address two tiny things that I noticed off screen that will just drive us crazy if we don't address them now. And maybe you've already been pulling your hair out and screaming at the screen when you noticed that I made just a couple of tiny typos. Is that when I have called this RPC GM change state remote procedure call, when we deal cards, I've written it as compile and not compile with a space in these curly brackets. And similarly, in the game manager, we notice that all these change game state requests have these curly brackets because that's what we use in Entromancy hacker battles. I haven't said for it to use execute with the curly brackets. I've just said execute by itself. And there's a reason for that we'll look at in our next video because of the way that we're going to handle text. But that will drive us crazy if we just keep clicking the button and they're not working and everything doesn't line up. So great. We've addressed those two things in our player manager and our game manager. If you haven't already, you probably have done better than I have. And I'm going to hit Control B to build the game. And while we're waiting for it to spin up for us, just mention that we're handling all the game logic in the background or under the hood, so to speak. But we're not indicating to the player using our user interface whatsoever what they're supposed to do or whose turn it is or anything like that. For example, we haven't addressed our bit points and variables or even the functionality of specific cards to affect those bit points and variables. And if I'm playing as the host and you log in as a client only, there's no way for you to know that it's your turn because you're the client only, or the direction of play, or which cards go where, and so on and so forth. And this initialize button, even though I click it once and then you click it, I could probably log to the console that now we're in the compile phase because now I can't click it again, and or you can't click it again, and neither can I. But it doesn't, this doesn't update, so that's not great. I could still play one at a time, which if you're in the trenches of making your own game, you'll probably realize quickly that it might be better to automate some of this stuff so you don't have to play an entire game every time, but such is the life of a game developer. So I'm hoping in the background that now that I've done all of this work, this button, when I click it now, it will actually run the execute command that will waterfall to do a remote procedure call and execute each program on my client. As you recall, when we put all of these cards in their sockets, these functions in their sockets, then we've created a program, and now we're going to execute that program. So what should happen is all my cards should go into my discard pile. Yours should go into your discard pile, or the player yard and the enemy yard, and the same on your screen. And either one of us should be able to click this button and make that happen. So I click it. They all go into their respective yards, and they do on your screen as well. It's not exactly elegant. It's not. They're just kind of like sitting on top of the yards. And let's take a look at that. So if I just close out of this and stop play and take a look at my player yard and my enemy yard, I see that the grid layout group is working just fine here, but the cell size and spacing and everything might be a little bit different from what I need to make everything look the way that I want it to. These are more like what we used for previously in another stage of development. So we need to make this work for us now. The cell size is fine to stay at 120 by 177, but I'm going to change the spacing, or rather not the spacing, but the the spacing to -105. And some of these items here are going to change. So I'm going to change my start corner to the upper left, the start axis to horizontal, the child alignment to the upper left, and the constraint can stay at a fixed row count. And I'll save it. And because I'm doing this on the object itself and not the prefab, I'll apply all of the overrides to the prefab. And I'll do the same with the enemy area. I'm sorry, the enemy yard. I think we derived these from the player area and the enemy area. So They don't have exactly what we need, but we can change that just pretty easily. We're changing this to -105 for the spacing, and the start corner to the upper left. And all of this is just things I've come across doing my own investigation and trial and error. So I'm trying to save you some headache here, although your game might be different in your needs, so you might have to try a bit yourself as well. Move that to horizontal, child alignment to the upper left, and we can leave the fixed row count as the constraint, and we'll save apply all of our overrides to the prefab. Let's spin this up again and see if that does this better. Cool. So we've come quite a far away from our humble beginnings with our one little drop zone, the yellow drop zone, and the way that we handled our cards. We've got a bit of game logic in there. It's not really surfaced to the user, but at least we know what's going on. So here we go again. Going to draw cards for everybody. Really wishing we had automated this, but what can you do? Play them one at a time. Okay, and now when I click initialize on either one of our screens, then they neatly go to our player yard and to our enemy yard, which is great. If we had different cards, you would be able to see that my cards, although they're going to my player yard here, they would be going to your enemy yard here and vice versa. But you know, it's working. What we probably want to do is, rather than just having this functionality where I have to look at hover over one card at a time, we want to have something that when I hover over my player yard, all of the cards are displayed on the screen, and vice versa, so I can see which cards you have played. So we'll address that in the next video as well, which is great. Awesome. We've done a heck of a lot of work here. We've moved from our simple 2D two-player card game into a more robust card game that has game logic based on one of my games, Entromancy Hacker Battles. Like I said, this may not be exactly the way that you want your game to work, but hopefully the concepts we're covering will be helpful for you in developing the game logic for your particular game. In the next video, which should be up by the time you get to this point in this video, and that I'll link at the end of the video, we'll take a look at how to handle the user interface for this so that we update things like our initialize button so it changes based on the phase of play, so that it highlights the turns of whose turn it is and which socket is available for them to play their function into, and so that they can mouse over one of the yards and see all of the cards in those yards. Importantly, too, at least for Entromancy Hacker Battles, each card has a specific functionality that, as we saw, if we hover over one of these cards called Ping, we should be able to gain 2 bit points at the end of the compile phase, and when it's played, it should increment the player who's played it. It should increment their number of variables. So we need to implement that too and have a way for different cards to derive from that type of functionality, but have their own functionality so that when we play one card, it might have a different result than another card. We'll address that in the next video as well. I hope this video has been helpful for you. If it has, please go ahead and subscribe to my channel and also like the video. If you'd like to do me a solid, please check out my books and my games, perhaps purchase one, or even more importantly, share them with someone and let them know about what we're doing here, and let them know about my games. I'd really appreciate getting the word out about Entromancy and my other games. You can check them all out at nightpathpub.com or nightpathpub.com/entromancy, or just entromancy.com. And stay tuned for more. Like I said, there's another video after this one, and let me know in the comments section if there's anything that you'd like to see, whether it has to do with computer programming in general, with C#, with Unity, with board games and card games, or perhaps JavaScript and Phaser. That's another one of my interests, and we'll look forward to seeing you soon.